Well, researchers over at the University of Texas have developed a sensor that catches silent threats to the power grid. We told you about this story a couple weeks ago. Threats like tree limbs, brushing wires before they spark outages or wildfires. Shannon Strank from the Cockrell School of Engineering at UT joins us now to talk more about this. Welcome and good morning, Shannon.
Thank you.
Look what she brought. She brought a giant prototype here. All right, so before this sensor, workers would just find the threats when they see them. So how does this sensor help crews?
Yeah, historically the sensing tends to live at the ends of the power lines.
So there are actual sensors right now, but even before this?
Even before this, but the impetus of this was trying to get rural power grids specifically, because they cover quite a large geographic area, a better visibility to their grid versus just seeing the signal at each end of a feeder and then trying to figure out where in between the problem might be happening. This can live on the power line and uses triangulation through GPS to tell you where the problem's happening.
Well, you tested these prototypes in Seguin over a month. So how many problems did it catch?
Yeah, so comparatively, we picked up about 10 times on the number of signals that they would normally have from a legacy system. So
what are the actual numbers, Shannon? Do you know off the top of your head?
So it was about 34 events, as we call it, versus about 5 events from the legacy system.
Okay, that's a big discrepancy. It's not like 5 to 7.
No,
right?
It was significant. So there's a lot of events that our traditional legacy systems just aren't designed to detect, that are increasingly more common, whether it's the tree branch rubs that you alluded to, as we get more severe weather events, or it could be things like we have a lot more power electronics that come in, like when we have solar panel arrays or wind turbine farms that put off different signals than the big, large rotating machine power generation historically.
I know we're looking at some video of it, but can we come and take a wide shot of this so Shannon can kind of explain what this is, where the new technology is and how it works?
Absolutely. So on the left, my left here, we have what's called the power module. So it's actually harvesting power off the conductive line. This is just an example piece of what a conductive line would look like up there. And it's powering the controller, the sensor, if you will, on the right-hand side here. So most of the intelligence lives in this smaller piece, but we designed this modular so that if somebody just wanted to operate for a short period of time that has batteries in it, it can do that. But if they literally want it to live out there for months at a time, it can harvest its own power.
So this is the power pack, and this is the actual device there. So what difference will this particular sensor make for utility crews actually out there repairing power lines during an event like a fire or a storm?
Sure. We all know that time of response, we all lived through Winter Storm Uri. It kind of landed home with us, how quickly we want power restored. So being able to detect where problems are happening in the course of the event and being able to target those will make for a faster response. Now, what we're trying to get after is actually figuring out where problems might be residing before a storm ever hits. So where trees might be interacting with the power line that could become a problem in the future if we have a windstorm, for instance. A lot of times utilities are just doing time-based maintenance. They go out and cut the trees back every 7 years. But if they can zero in on, like maybe there was a construction project that now upended a tree that's now hitting a power line, they can go and do targeted maintenance that way.
What a brilliant idea. All right, so for the next step for these sensors is monitoring data center power usage. Can you talk more about that?
Yeah, so there just isn't a ton of data on what the data centers do on the power grid today. Of course, ERCOTs of the world have been trying to do modeling and simulation of what that might look like in terms of load on the power grid and effects on the power grid, but having something like this gives you real hard data that you can use and work off of to modify protocols in the future. So it just gives you real-time information that you can use to help understand what the impacts are and therefore how the utility might modify its protection protocols, for instance, to be able to adapt to this different grid that is up and coming with the higher penetration of data centers.
That is so valuable. When can we see that actually start?
So we've gone through 2 field demonstrations to date with 2 different co-ops. Both were successful. We're about to deploy again at the end of August for a 3rd demonstration. So really, the technology is proven at this point. We're really just seeking a commercialization partner to potentially bring it to market.
Well, I'm sure there will be tons of companies that will want to partner with you, one would think. Shannon Schreck, thank you so much for joining us and enlightening us with this new technology.
Absolutely.
Appreciate your time.